Hi, welcome everybody. Welcome to the March Gen 3 Community Forum. Thanks everybody for joining. Uh, Today, I'm excited about the group of presentations since there's been a working group, the CSOC working group. So this is a group that's focused on improving Gen 3 deployments, particularly for those organizations that run more than one Gen 3 system, although that's not required. This group has been meeting for over a year now, not in secret. All the meetings are public and the recordings, but I'm not sure that the entire community has really seen the work that's been going on. So today we wanted to focus primarily on work that that group has been doing for the past year, plus kind of an additional presentation at the end that wasn't really covered in the group, but is does relate to Gen 3 deployments. So can you do the next slide, Faye? And I'll just introduce the speakers and then we'll pass it along. So first today, we're going to hear from Jawad Qureshi at the University of Chicago, who's going to show the CSOC dashboard. Then we'll hear from Alan and Jimmy at Indiana University, who are going to talk about using Crow, which is an interesting tool that you may be interested in learning more about. Then we'll hear from Gordon at the Australian Biocommons, who's going to talk about using AWS CDK, Argo CD, and Helm for their setup. Then we'll hear from the Open Commons Consortium, who will talk about their CSOC dashboard. And then finally, we'll hear about actually this we're going to hear from Paul instead of Luca from the Data for a Common Good group on using Gen 3 as a platform. So that'll be an interesting talk to hear about that. So as always, please feel free to put questions in chat. Hopefully we'll have a couple minutes at the end of every presentation. And I'll just ask the speakers to try to keep it to 15 minutes total, including questions. I'll try to give you a reminder if it seems like you're going over. So with that, I'll pass it along to Jawad.
Thank you, Michael. Let me get ready here. Yeah. So basically, Michael, you introduced the CSOC dashboard. So just to give a little bit of background and context, like CSOC, the Commons Services Operations Center, is a concept basically that we've used before, but now with an actual UI. It sort of encompasses the tools required to bring up the infrastructure, do a deployment, and also some monitoring tools as well. So for us at CTDS, we've always deployed into AWS using EKS, and we have Terraforms to do that. A few years ago, we split them out from a monorepo into separate repositories, and that's also when we did the move to Helm, which enabled other people to deploy Gen 3 onto their own infrastructure. So that is still the de facto way of deploying Gen 3. The CSOC dashboard basically builds up on top of that and sort of in an opinionated way of deploying Gen 3. So you can do next slide. Thank you. So we built sort of a dashboard that builds on top of stable APIs such as the Kubernetes API and built in a few different things to help solve the challenge where researchers can manage multiple Gen 3 deployments across different environments, whether it be production, development, or testing, so that it's not complex and time consuming. So we built a dashboard from ground up that sort of helps with the whole life cycle of operating a Gen 3 data commons or ecosystem. You can do next slide, Faye. Okay, so a little bit about the architecture. So we have a server agent type architecture that basically builds the entire portal. So the way it works is that you deploy a central server, which hosts an API and a front end, and then you can deploy agents to all of your different Kubernetes clusters. The idea is also that you should be able to spawn these different clusters as well from this portal. And we built in different tools to accomplish basically that. The communication is initiated by the agent back to the server so that you don't have to open up firewalls from this management cluster all the way back to where your Gen3 is running. So this basically simplifies the provisioning of that part. Um, the front end is written in Next.js, and it integrates on top of the Go APIs that we built. And there's an auth component built upon Keycloak as well. And then it integrates with Grafana and Argo CD to build out the different dashboards and views. And for security, it leverages MTLS, so mutual TLS, which is basically the agents verify the server and the server verify the agents as well while it's talking, in addition to Keycloak, where we do user authentication. You can do next slide, Faye. Yeah, I mentioned a little bit about like the different architecture, but if you're interested in the technology stack, the front end, as I mentioned, it's Next.js, uses server-side rendering, uses Mantine UI to build beautiful dashboards, and Mantine UI is a React component library. And then through the REST API, it connects to the backend, which is written in Go. And the backend also integrates on top of different Kubernetes API natively, so we can build out different views and get the health of every deployment that you have, as well as we can control all the different clusters from a centralized point of view. So the infrastructure is obviously very Kubernetes native and cloud agnostic. So this is built so that it can be deployed to AWS, Google Cloud, Azure, or even on-premise clusters. We're testing it right now with OpenShift. But yeah, and it's all built on top of the Helm charts that we already have. Yeah, so we can do next slide. One of the components that we have in this dashboard is the deployment management. So you can start a Helm deployment from this dashboard, and you get a sort of a deployment wizard that guides you through the setup of Gen3, and you can select the different components that you want. And in the end, you basically get a pre-configured values YAML file that you can click a button and it will also deploy it for you, or you can take that values file and deploy it yourself. And then there's also a at a glance environment health dashboard. So while you're managing multiple environments, you can basically go in and check like if the environment that you are working on is healthy or what's wrong, go check the logs. And it's all from like a single view. We can do the next slide. Another feature that is really cool and nice is the database UIs. As you're developing and managing and operating Gen3s, inevitably you're going to have to check the databases at some point, especially if something is not working as it should, or you're just curious as to how things are being structured in the back end. So we've had some like utility functions before just from the terminal where you can go and get like a shell into the databases, but now we can also get a UI where you can also run queries, inspect the schemas, and troubleshoot data issues, as well as an Elasticsearch UI that you can do manual searches to see that your ETLs are doing what they should and whatnot. Yeah, we can do next slide. And as I mentioned, it has a full Kubernetes dashboard, which is just natural to build in once we're building on top of the Kubernetes API. So you can check every sort of resource that is in your Kubernetes cluster with a nice UI on top. And it also builds on top of the Kubernetes RBAC integration. So you can restrict the agent itself to only have certain rights. And if you do that, then the entire dashboard will also be restricted in what it can do in the certain clusters. I'll do a quick demo of it afterwards, and hopefully it makes a little bit more sense. Next slide. And then the other component that we built into it is the infrastructure provisioning component. So we've always leveraged infrastructure as code. and we use Terraform to deploy to AWS. But the way we built infrastructure as code integration into the CSOC portal is as long as the infrastructure as code can be containerized, it can basically be ran from the CSOC portal. With that in mind, we can get support for EKS, which we already have, and GKE in Azure and other basically big clouds. We can also integrate with other tools that you will see later on in this presentation, such as Crow from Alan and his team, and then CDK from the Australia Biocommons. Um, but if you don't want to manage infrastructure through this portal, that's totally cool too. You can only do partial or bring your own infrastructure as well. Um, okay, so I'll borrow the screen for a second, Dave. That's cool. And okay, let me also turn off my notifications. Um, okay, and let me know if you guys can see this dashboard.
We can see it.
Perfect. Thank you. Here, I'll start by this first view. This is basically the environment that is in my context right now. Right now, we've connected two of our clusters. So our dev cluster, which has all of our CI and QA and development environment. Then we also have another cluster that we call unfunded. Here, all of the environments that are deployed to these clusters will come up. For the purposes of this demo, I've just chosen QABRH, the Biomedical Research Hub QA environment, to set up the context. So once we go home, we basically get to see like all of the Gen3 services that are up and running, and we see like one of them is not healthy, it's actually down. We can click on it and we can sort of get a little bit of a view of what's going on. We can take a look at the logs, and the dashboard service is basically just an S3 mirroring. Basically, you can host like static files in S3, and it seems like we haven't set up credentials correctly here. So the log portion here is pretty nice that we can just get just a couple of clicks away by going down this way and just clicking on the logs. Something else that's cool that was developed by the Google Summer of Code intern last year that helped build this as well is the shell component. So we actually get shells into the different pods if we click the shell part. This is pretty cool and something that we will build on top of it more. I've noticed like more and more cloud providers are providing something called cloud shells, um, where your credentials are already set up and you basically get a terminal with tools built in. So as we start rolling this out more internally and moving away from what we call the jump boxes, more of that functionality will probably like be built into this portal itself or into like a cloud shell in here. Um, the Gen3 deployment wizard is also kind of cool. So I can select the cluster that I want to deploy the Gen3 to. And then I can give it a name. I should probably not do uppercase. And then you can give it some sort of a host name. Um, yeah. Then you can also choose if you want databases automatically created or not, or if you want to create the databases yourself. And then you get to choose like what components of Gen3 that you want to deploy. And if you hit this debug mode, you can see that the whole configuration of Gen3 is being configured for you in the back end, basically. You can go through this entire wizard. You can set up the different login providers, the different OutZ stuff. You can configure your workspaces, add and remove different containers. If you're used to the YAML, this isn't like revolutionary stuff, but it like lowers the barrier to entry for deploying different Gen3s, especially within an organization that has already set this up. We can make this sort of a little bit nicer. Um, I talked a little bit about the database UIs. So We can take a look at the search cluster. So this is basically the Elasticsearch UI for my current environment. So this is a shared Elasticsearch that gets shared across all of our dev environments. Here you can execute like actual requests and like start exploring the data in there. Um, I won't actually do any other like data queries, but we can look at some monitoring queries to see like what our nodes are looking like and all of that. So if you're interested in taking a deep dive into Elasticsearch, this gives you sort of a nice interface into that. Um, then there's also a Postgres database one. So I'm going to use my local one because this is all just running on my laptop and there is no risk of any data being shown here on this demo. But basically what we're seeing here is the fence database, all the different tables. This is built upon something called the PG Web. And here you can see what the Gen3 developers are doing, or if you're a developer yourself and you're building something that requires a new table, this sort of gives you a nice view instead of having to go through the whole pSQL shell. Um, you can switch databases as well. It launches a new container and then mirrors the UI once that container's up, similar to sort of how our workspaces work as well. Um, yeah. So this is basically the Sheepdog database that I just set up in my dev environment right now. Um, okay, some other niceties that we have here is the Argo CD integration that I just talked about. So you can just hit this button and it like triggers an Argo CD sync, although this one did not finish. Um, yeah, and then you can also take a look at all of your different Gen 3 deployments or regular Helm deployments as well on any cluster. And if they're deployed through Argo CD, you will get this nice Argo CD icon. And since Argo CD reports on health, we also get to see like the health of the different environments at a nice view. Um, I don't know, do I have time to show one more thing?
We have a minute left.
Okay, cool. So this is the Terraform integration or the infrastructure as code integration. So you can run it, if you're running it locally, you would run it in Docker. Or if you're running it in a deployed environment, you run it in Kubernetes. You can set up some credentials to like where you would run it from. Um, but here is basically the end UI. And it does similar things to the like the other Gen 3 deployment UI, but it launches a container, keeps track of your state files, and then basically executes this Terraform, which is the Gen 3 specific Terraform. Um, I would love to get like the CDK stuff as one option of deploying like more environments or the Crow stuff next. Because Crow basically builds on this pattern where you get one Kubernetes cluster as your main management cluster, and then without having anything else, basically no containers, nothing. You set up CRDs to spin up new clusters. And I think I'll leave it at that and tee up Alan and his team. I hope they're next to talk to more about Crow.
Awesome. Thanks, Jawad. I think we'll just keep moving. If people have questions, type them in the chat, or hopefully we may have a few minutes at the end. So yeah, thank you, Jawad.
Yeah, just perfect segue. Thank you. So as Sharad said, we're going to talk very briefly, Jimmy and I, about this thing called Crow, which we discovered beginning of last year, got very excited about, and we'll tell you why. Next slide, please. So you heard Jawad describing Gen3 admin. He used the phrase Kubernetes native many, many times, which we love. If only everything worked like Kubernetes did. We love Kubernetes. And to be clear, I love Terraform and I love Helm, but I have kind of a love-hate relationship with both of those tools. Love them when they work, and I hate them when they inevitably let me down just when I need them most. So we've struggled with this. All of us, if you've deployed any app, be it Gen3 or anything else, frankly, you've probably encountered some of this fatigue that some people have deemed the complexity wall. So luckily, we're not alone in this. If you'll go to the next slide, please. there's a really smart group of people at AWS, Google, and Microsoft who came together to address this issue, and they're addressing it because they're hearing about it from their customers, folks like us who are complaining about that complexity wall and how much they're struggling, in particular with rolling out these internal developer platforms, which is very much what I think of when I think of Gen3 admin. I think of it as like, the IDP for Gen3. And so these folks, and to be clear, like in AWS, this is actually the EKS team. There's a subgroup of people from the EKS team, and in Google, it's a group of folks from the GKE team. They've come together to create something they call the Kube Resource Orchestrator, colloquially known as CRO. This is an open source project, Kubernetes native. You can see the link there. They ultimately would love to see this just be part of Kubernetes itself. So maybe, perhaps someday, who knows, this could be part of a future Kubernetes release. But in the meantime, what it is, it's still in pre-production, but it is a lightweight engine that runs inside your Kubernetes cluster, and it gives you the ability, and this is the secret sauce, to create custom APIs, but without all the pain associated with that. People were doing that. They were creating their own controllers, but that's difficult to do and hard to maintain. Next slide, please. So the way this looks, if we look at this, when you have CRO installed, CRO gives you this ability now to create a definition of your application, this group of resources. We just use resource to describe all the things, but this is everything in your app. Your app has your app code, of course, all your Kubernetes things. That's the stuff we're very familiar with. Your ingress, your deployments, your service accounts and services, and so on and so on. But also the infrastructure, because your app needs a place to run. And so you might say, well, I need to create S3 buckets and Aurora databases and all those other things. An EKS cluster maybe for my application to be deployed. And so you define all of that using CRO now, this collection of things, and that becomes this custom API. And from that API now, it's just like any other Kubernetes API. We can call that API, and it will create for us the thing that we want, which is our application. So the idea is just create a Gen3 API. Just give me a Gen3, and you just provide the necessary details, and then Kubernetes does what it does. Kubernetes takes that API call and manages and enforces the state without you having to write any additional code. Next slide, please. If you think about Gen3, imagine a Gen3 definition in CRO. We call these resource graphs, resource groups. You define all of the things that you need, all the infrastructure components for a Gen3, all of the application components for a Gen3, and you capture that in your management cluster, this idea of the central cluster where we're going to control everything from. And then when you want a new instance, say a new Gen3, you can come along and just call into that API. Just say, give me a new one of those. You provide the values that you need to get the desired outcome on the back end, and then Kubernetes does its thing. It takes that API call, and using the magic of CRO and what you've captured in that resource graph definition, it will create your thing. Next slide. And so to quickly wrap things up, we have started going down this path. Jimmy's going to talk about all the work that he's been doing for several months now. We've created a repository here where we're building this out. Our goal is nothing less than creating a set of CRO graphs that we can use to deploy Gen3. Right now, we've got an AWS deployment that works. Jimmy's got the code to bring up the hub. You need CRO, of course, and you need to install the infrastructure controllers if you don't already have those in your cluster. And then he's got the resource graphs to go along with that. It's, of course, integrated with Argo CD. It's got some really nice stuff going on there. Looking ahead, as I said, we want that entire collection of resource graphs, and we want this to be multi-cloud. The idea is you could have your hub running in Google or AWS or Azure, and then be deploying to any of those targets as well. It should work because, again, we're doing everything Kubernetes native. That's the whole idea behind this, is to enable plays like that. So with that, I will turn it over to Jimmy. We can probably jump a couple of slides.
All right, so here we have the Argo CD dashboard. And as you can see here, we will be deploying our infrastructure in stages. Right now, you're seeing the first stage, where we deployed shared components that are used by all of the spokes, so to speak. So if you're making multiple deployments of Gen3, you're going to have multiple spokes, which you'll be deploying infrastructure for and deploying the application into. So these are the shared resources. The shared resources would be the IAM mapping and controllers for Crow, and say ACKs if you're deploying to AWS, GCCs if you're deploying to Google Cloud, and the ASO if you're deploying to Azure. Next slide, please. After deploying the controllers themselves, you're going to be deploying the definitions for your resource graphs. So the resource graphs would be containing both the infrastructure and the application. You might have one resource graph deploying everything. You can have multiple resource graphs that are interlinked, and they will be deploying the infrastructure. This in our case right now, we just have one deploying infrastructure. That's why you have fleet infrastructure instances right here. After we deployed the graph, the instances will define for each spoke what you want for that spoke. And we do it per namespace here. So we have spoke one. Spoke one is the name of the namespace, is the name of the customer. We deploy all the infrastructure for spoke one using one instance. Next slide, please. Now, after you deploy the infrastructure, all that's left is to deploy the Gen3 application. And currently, Gen3, according to Gen3 Terraform, you have two Helm charts that are deployed, which is the cluster resources and the Gen3 application, which we've also split in our deployment here. As you can see in the slide. Next slide, please. Okay, so this is sample templated IAM role selector. It's deployed per spoke account. So Helm chart, we use it to deploy this. And the reason why we use the Helm chart here is so that it can be repeatable. We could also use the resource graph, but we just chose to use the Helm chart here. Next slide. And here is a basic overview of our resource graph. Important sections here would be the kind, which is the resource graph definition, the spec, which defines the instance that we're going to deploy. Here, the spec in here has a spec that's .schema.api version between lines 8 to 10 on this page. Now, we use that to define the instance the basic instance. And that is what we template for all of our instances that we're going to use. You can also see resources here that are going to be deployed, or resources that we depend upon, like the spoke namespace. We depend on the namespace to determine stuff that we're going to deploy into that namespace. And then you see the VPC, Elastic IP, Internet Gateway, all components for AWS that we are going to be deploying into the namespace. Next slide, please. And here is a further breakdown of what the spec would be. Like I said, the spec templates what the instance would be. Here we have defaults for the spec. And if you have defaults for the spec, you don't particularly have to define those fields if you're not changing them. Please, next slide. Here we have a basic resource. This just defines the route table, a DB route table. And as you can see, there are fields here from the schema.spec that are templated to be able to define fields for our DB route table. As you can see the name here, that is on line 437. You can see schema.spec.name-dbrt. That is the name of the DB that you're going to see on AWS. And we have adoption policies and deletion policies here, such that when you delete the kind object in the cluster, what happens on AWS? Do you want it to cascade the delete to AWS? Do you want it to be able to adopt resources from AWS if they're already existing? Yes, management is very easy with this with the Kubernetes API that is provided by Crow. Next slide, please. And then you have a sample output resource here. So when we finish deploying the infrastructure, pieces of the infrastructure are used to template a Kubernetes secret that we're going to use for the deployment of our Helm chart for our Gen3 application. As you can see here, we have the Aurora endpoint there. We have the EKS endpoint there. Other bits of data that Gen3 would need to template the application deployment. Next, please. And you also have the status part of the resource graph. Now, your status part of the resource graph is for an operator. If, as an operator, when you want to start investigating issues with your graph, you want to be able to know if particular components got deployed properly. You want to be able to see their IDs to be able to manage them all from one place. This field gives you a means to do that. Next slide, please. And now we move on to the infrastructure instances themselves. Let's move on. Next slide. Here is a sample infrastructure instance of what we already have deployed on AWS. We have a Spoke 1 instance. The name of the namespace is Spoke 1. We also named the resources, templating it with Spoke 1 dev, because it's a development environment that we're using ourselves. These are just some of the fields that you can customize on our resource graph. You could actually make any, you can make any of these fields that on AWS that you fill in on AWS. You can make them customizable here, but these are the fields that we chose to use for our graph. Next slide, please. This just shows other bits of the same infrastructure instance. Next slide. So as I said earlier, we deployed the Gen3 app after we deploy the infrastructure. This is just to show us that. Next. Okay, so we used an Argo CD to deploy the Gen3 application, and this is just an excerpt of the manifest for the Helm chart. All right. I mean, if I still have time, I would like to show you bits of what has already been deployed.
We have like another, can it be within like a minute or two,
A
Jimmy?
minute will be fine.
Okay. Faye, can you stop sharing? Okay.
All right, so here are deployed resources from our in our Spoke 1, as I said. We have the resources deployed here: KMS keys, VPC, Internet Gateway, subnets, all managed in a report file that we have developed a script for in our repo. This is just to show. And we've deployed everything all the way down to the Kubernetes cluster that would be going in. Here's our Kubernetes secret. Here's our cluster. And here are our resources. We've already deployed cluster resources, but we've not yet finished deploying the Gen3 in our test. That would be all. Thank you.
Great. Thanks, Jim and Alan. Apologies. That's really cool. I hope if people have questions, they can put in the chat. Hopefully we can come back to it because you're showing us some cool stuff. But for now, we're gonna move on to our next speaker. Gordon, are you here?
Yes, I am. Can you
Okay.
hear me?
Yes, we can. Take it away, Gordon.
Thank you. So today I will be walking you through how we bootstrap Gen3 using AWS CDK, Argo CD, and Helm. and how this approach allows us to operate multiple independent Gen3 data commons without scaling our infrastructure team. This model this is the model we are currently using in production. To explain why we built this model, I will start with the operating context we work in. So we have multiple independent Gen3 data commons, and each data commons has its own account structure, meaning AWS account, with a separate environments for test, staging, and production, where each environment has its own EKS cluster. And most important, we don't share EKS clusters across data commons, which provide us with the isolation boundaries for both operational and the governance perspectives. However, once you choose isolation, then you have these scaling challenges. Next slide, please. So each Gen3 data commons requires a full infrastructure setup. That includes networking, IAM configuration, EKS cluster provisioning, WAF, Elasticsearch, GitOps, Bootstrap, and also control promotion between environments. And you can imagine if this work is done manually or semi-manually, I mean, the operation burden will grow linearly with the number of data commons. And sharing clusters could reduce infrastructure costs, but it will also increase blast radius and operational coupling. So the real question for us became, how do we scale Gen3 deployments without scaling engineers? So our answer was to standardize the bootstrapping process. So our solution is a layered deploy model. For each data commons, we use a dedicated tooling account. In that tooling account, we run several code pipelines, which executes CDK infrastructure deployments. The pipelines assumes cross-account roles and deploys infrastructure into separate test, staging, and production accounts. The CDK boost. Still the previous slide. Yeah, thank you. CDK bootstraps the foundational infrastructure with the things like VPC networking, EKS clusters, IAM roles, WAF configuration, and of course the Argo CD. There are also additional AWS resources provision as part of this process, such as S3 buckets, secrets manager, SNS topics, SQS queues. All these are used by SSCA dispatcher, but we have omitted these here just for clarity. Then Argo CD manages the Helm-based Gen3 deployments. Okay. To make this a bit more concrete, I'm going to show you how this looks in terms of the overall account structure across multiple data commons. Next slide, please. So this diagram shows how multiple Gen3 data commons are structured in our AWS environment. So each data commons has its own tooling account, as I mentioned earlier, which hosts the infrastructure pipelines. These pipelines deploy infrastructure into environment-specific accounts, typically test, staging, and production. And each of those environments run its own Gen3 deployment. At the platform level, we also integrate shared services such as a central networking account and central monitoring account. So the network account, primarily we use that for VPN access, where we would connect via VPN if you want to access things like the database or the Kubernetes shell. And the central monitoring account, that's what we have Grafana monitoring. So this structure allows us to maintain like a really strong isolation between data commons while we're still benefiting from the shared operational capabilities. Next slide, please. So this is a screenshot which shows the actual pipeline from one of our Gen3 data commons. You can see from left to right, you can see the pipeline promoting infrastructure changes through microenvironments. So in this particular deployment with UAT, staging, and production. So you can see like in each stage, it includes a pre-flight checks. So we check like, things like SSM and make sure the configuration is there before actually starting the actual deployment. And then you have there are manual approval gates. And then the CDK continues to deploy through CloudFormation. So this pipeline itself lives in the tooling account and uses cross-account roles to deploy infrastructure into target environment accounts. So basically, this means infrastructure changes are promoted in the same way we would promote software releases. The next slide, please. So AWS CDK, it gives us a consistent infrastructure baseline across all environments, and standardizes networking, the EKS clusters, including node groups, the IAM roles, the WAF integration, the RDS, Elasticsearch, and also the bootstrapping of Argo CD. So since we have everything in code, every new environment inherits the same architecture and the security posture, rather than redesigning infrastructure for each data commons, we simply intershade the same pattern throughout. Thank you. Once the cluster is bootstrapped, Argo CD takes over the application lifecycle. So basically, we use Argo CD to watch the Git repository, which has defined the desired state of the platform, and Helm charts define the Gen3 services. I mean, we're all very familiar with the Helm charts, which are really good. If drift occurs, then the Argo CD will automatically reconcile the cluster to match the declared configuration. Next slide, please. So we had a few questions, why we don't share EKS clusters across data commons. I mean, the main reason is isolation, and each data commons may have independent governance requirements, different security policies, separate funding, and different operational timelines. Sharing clusters would have introduced cross commons RBAC complexity and increase the potential blast radius of operational issues. So instead, we isolate by account and by cluster. and we standardize all the infrastructure pattern. So I mean, the idea is that we scale by sharing infrastructure. I mean, and we don't scale by sharing infrastructure, but we scale by standardized infrastructure. Next slide, please. Um, our architectures enables us to operate Gen3 at scale. We can onboard a new Gen3 data commons without redesigning the infrastructure. We maintain a predictable security baseline across environments. And all infrastructure changes can be promoted through control pipelines. And GitOps reduces operational drifts between environments. And in practice, standardization becomes our scaling mechanism. And with that, that'll be it. And I'll pass over to Steven.
Thanks, Gordon. Are there any questions? We have a few minutes. There is one question, I guess, from Maxime in the chat, Gordon, that relates to all, but I guess you could answer for your work.
Okay. Let's see. Yeah. So I'm kind of honest as speak for our CDK. So I would say it's fairly mature because we're using this for production, and this is the pattern we're gonna continue for the foreseeable future. And the reason we're using CDK because we are 100% AWS shop, so it just makes sense to use AWS CDK.
Yeah, I can speak to the Gen3 Terraforms. I would say they are fairly stable too. We've been working on them for close to a decade now, and we've been using them for our production deployments for all of our clusters. So I can definitely vouch for the Terraforms as well, if you want to go down that path. Yeah.
Jawad, do you want to say anything about the dashboard and when that might be available or?
Oh yeah. I mean it's open source now. You can start deploying it. There should be Helm charts in the repository. There's also Docker Compose that you can use, which is sometimes easier for people to get started with. There is an architecture document in there, shows you like how it's built up. Yeah, and then I mentioned we use Keycloak to manage the authentication and authorization portions. The authorization is basically built-in code within our Go API, but the authentication and the bootstrapping of Keycloak is done through the Keycloak operator in there. So if you wanted to deploy it to Kubernetes, you basically use the operator pattern to deploy that. What else? If you do it through Docker Compose, I think the Docker Compose should have CSOC, sorry, the Keycloak already added in there. And I would love for more people to try this out. Reach out to me either on Slack or something. If you need help setting this up for your organization, to basically make the monitoring and managing and deploying of Gen3 easy for your use case. Yeah.
Great, thanks. Are there any other questions for Gordon? Okay. All right. Thanks, Gordon. Okay, we're going to move on to our next speakers, who are from the Open Commons Consortium. So we're going to hear from Stefan and Irvi, who will talk about building and managing multiple data commons and OCC's CSOC. Take it away, guys.
Thank you so much. My name is Urvi Shade. I'm a senior software engineer at Open Commons Consortium, and me and my colleague Stefan would like to demonstrate how OCC is building and managing multiple data commons in our CSOC. Next slide, please. So the main objective with that we are trying to achieve in our CSOC is to have a central, streamlined way to manage and monitor multiple data commons within the CSOC. At the same time, we want to automate the deployment of fully functional Gen3 environment, handle version upgrades smoothly, include infrastructure code, and implement CI/CD for any new configuration changes. Throughout all of this, we follow the best security practices and aim to maximize the reuse of existing code so that our processes are efficient, reliable, and scalable. Next slide, please. Now let's take a look at the architecture and see how OCC is managing multiple data commons within our CSOC. Next slide. So as you can see in the diagram here, on the left, we have our main AWS account, which serves as our CSOC account. Inside that, we have Rancher implemented. Rancher is a management UI that makes handling multiple Kubernetes cluster much easier. It manages different Kubernetes cluster for our separate data commons. For added security, Rancher is protected by an AWS WAF. In the diagram, you can see the Rancher is connected to MC2DP and VPODC. Those are two separate Kubernetes cluster in two different AWS accounts. MC2DP is a data mesh where VPODC is a data commons. So within this Kubernetes clusters, you can see there are this Argo CD implemented. Argo CD, as we discussed before, is a continuous deployment tool that connects to the Argo GitHub repository, ensuring that our services are automatically updated and deployed whenever there are new changes. Both MC2DP and VPODC are also protected with WAF for maintaining security. So this setup allows us to centrally manage multiple Gen3 environments while automating deployment and upgrades, maintain security, and keeping our infrastructure consistent. Now I will hand it over to my colleague Stefan, who will take you through a live demo, and he'll also cover the key benefits, some practical changes we faced during the implementation, and the next step that we're planning to take. Over to you, Stefan.
Thank you, Irvi. Could I share my screen, please? Thank you. Okay. Right here, this is a Gen3 Commons that is running currently in our AWS that was set up with our current method. Basically, we've copied the K9DC, the data commons that we had up, but this is running within our CSOC environment. And I basically have all the data uploaded and everything seems to be running smoothly. So let me take you over to Rancher. I'll go here back to the home. And here you can see that we have two clusters that are implemented right now. And basically give you all the Kubernetes information about that. We've called this environment Wind Tunnel because it's a sort of experimental site. And if you go into here, you can see everything about Kubernetes from Rancher. You can get information about, what's installed, your workloads, all your deployments, the different jobs that are available. Rancher is a pretty nice tool. And
Stefan?
within that,
Oh, sorry to interrupt.
yes, go ahead.
Can you zoom in at all?
Oh, I am so sorry. Yeah. What is
I don't
the
know. It's okay if it doesn't work that way, but
me see if I can.
nice. Thank you.
Okay. So this will show you all everything that you have going on. A lot of it, some of it is Argo DC, which again, like Irvi said, we use in all of these sort of clusters. And within each cluster has its own Argo CD setup. So this is the one running for Wind Tunnel, and this is run, and this endpoint here is run and maintained by our Terraform structure. So what's setting all of this up is a Terraform code base. Okay, and then that Terraform code base then will talk to our deploy code base. We also have a Git repository that Argo CD looks at, and so Argo CD will look at that repository and sync off of that. This is everything that Argo CD runs, and basically there's a lot of external things like external secrets and DNS and basically handling a lot of the piping. Here you see by the red here, the wind tunnel OCC, that is the Gen3 application itself. But we also have other stuff, things like pgadmin 4. We have a pgadmin running on this cluster so that you can look at database information here. And like Irvi said, all of this is protected with a WAF. So right now this is keyed to my IP, and we're going to introduce more security around that soon. Also, you've got things like Loki and Grafana, and we're going to implement logging and being able to look at monitoring to see how this is being used, what people are downloading, etc. But if you click into here, you just basically get a similar view to the Kubernetes cluster, but this time from Argo's point of view of what it's keeping up. So you've got all the deployments in Gen3. You've got these external secrets that are up and running, and you can look at the different jobs and other things that it isn't showing you, and like what's healthy, what's not, etc. And then all of this, let's see if I can. Where is we have this Terraform. Right now, this is I think it's a private thing, but we will wanting to be open sourcing this, which is a Terraform plugin that you can use specifically for Gen3. And then if I can find it, you just go to my own. We have a repo here that is our deploy repository. This is where you set everything up, and here we've got like the Gen3 files, and that in turn was created by the infrastructure where you have Terraform files for each cluster that are defined here in the Terraform. And then that is it for the demo portion of this, and go back to the slides. Thank you. Yeah, this is sort of a visualization of everything I kind of just showed you. But basically, Argo watches for the changes in these Gen3 configuration files, and will update as soon as you do, as soon as you send things up. I think everybody who has presented so far has used some similar thing to this, if not exactly sort of the Argo CD setup. Next slide, please. This is, again, the Rancher. I included this in the slide, so you can sort of peek at this if you didn't get a chance to see. Next slide, please. This is another Rancher viewpoint. Next slide. Same here. Next slide. This is the Argo that I was showing you. Next slide, please. And then this is the detailed view of it. Next slide. So the benefit of this, of what we're doing, is that we have a paradigm where all of our data centers are in separate AWS accounts. There you could have, and all of these accounts are underneath our CSOC. So we have a central CSOC that we can go into, and then all of our AWS accounts are underneath that and managed by that central CSOC. So this having things uniform with Terraform helps us, do best security practices and ensures each commons is properly secured. And we have a WAF, which basically will let us have fine control over each section of things. This setup, it's less complex in terms of management. Rancher gives you a central view of all these commons, so you don't have to go into each one and check that out. The Argo seed is built in. It gives us continuous deployment. It uses existing Gen 3 Helm charts, and it also ensures that logging and monitoring will be built into each commons. Now, all of these key benefits, I think, are in every other presenter who has done this has locked onto these benefits. Whether they're using Crow or having a front end application, but this is sort of the benefits and that I think are common to everybody who's doing this. Next slide, please. So the challenges that we have found in doing this is secrets management can be difficult. Being able to make sure that you have your secrets set up properly instead of going in and manually defining them afterwards. Automating that process and keeping it secure has been a challenge that we're overcoming. The microservice specific configurations, so things in Gen 3 each require their own special configuration that goes into implementation of lesser known parts of this. Sort of being new to working with Gen 3, I found that some of the really, really detailed parts of Gen 3 are sort of like you really have to dig into it to find exactly what needs to be done with a lot of these pieces, because there's some pieces that are in every data commons pretty much in Gen 3 that aren't really talked about as often, but they still need to be part of the infrastructure. And incorporating the latest Gen 3 developments, basically we want to make sure that if we move to if there's new things that are being created, that we can incorporate them into what we're doing. And then we've been working on improving the documentation of the Gen 3 ecosystem. So as I go, I'd like to, I'm trying to give feedback into areas where we can improve developer documentation. This does cover similar ground as Gen 3 Terraform, but also the Crow that people are working on. And right now, this only works with AWS, although a similar plugin could be created for Google Cloud. Next slide, please. So what we're doing next is we're going to create a standard operating procedure document, basically, that will say, when we want to spin up a new commons, here's what we need to do, and here's how you maintain a commons using this Terraform plugin setup and this GitOps repo. We're going to recreate the Bloodpack data commons. We're right now setting up a development environment. And when that is proven to be to work for us, we're going to transfer from the old production environment to this new CSOC environment that we have, and we want to make a smooth transition from that live service from the old one to the new setup. And eventually, we're going to gradually onboard the commons that OCC is sort of responsible for into the CSOC framework. And then we want to establish a unified governance model across the commons. So when people come to us and they want to get access to data, we want to make sure that we are able to maintain the governance around that properly. Working on it's loosely called a governance portal, but basically we want to make sure that we can automate and keep track of everyone that has access to this data via governance, and then make sure that we're keeping track of paperwork and making sure that everything is up to standards. That is all from me. Thank you very much for listening to the presentation.
Thanks, Stefan and Irvi. Are there any questions for the OCC team? Maybe we could handle one question. All right. I think we'll just move along, and thanks, Stefan and Irvi.
Thank you.
And now on to our final presentation, which admittedly wasn't part of the CSOC working group, but we heard about it and thought it sounded so interesting and still falls under the category of, cool things people are doing with Gen 3. So we invited our colleagues at the Data for Common Good to tell us about how they're using Gen3 as a platform, which I think could be of interest to the rest of the community. So, Paul, it's all yours.
Hi, my name's Paul. I'm part of Data for the Common Good at the University of Chicago. And today I will be presenting on how we expanded the Gen3 framework outside of data commons and data meshes. And in our case, we used it to build a clinical trial matching tool called Gearbox. Next slide. Okay, so Gearbox is a decision support tool used by clinicians and nurse navigators to identify potential clinical trials for their patients. It is currently being used to help children with relapsed acute myeloid leukemia. Next slide. So children with relapsed AML will traditionally go on traditional chemotherapy and do additional testing while their medical support team will manually look for ongoing clinical trials, which can take up to weeks to months, depending on various access factors like the size of their medical team. Are you in like a rural medical system, et cetera, et cetera. And next slide. And so Gearbox aims to cut out those factors and help patients get matched to trials within 48 to 72 hours. Next slide. So again, like the overall goals of Gearbox, it's to try and match patients to trials within 3 days. And then the idea is we want to design it so that it's very quick to use and make it very simple to understand how to use it, because the goal is to not only have medical staff use it, but also have families and non-medical personnel be able to use this tool. It's designed to help lower and cut out those sort of access restriction factors to getting clinical trials and make it as smooth as possible. We want to try and design it so that we can scale it to other diseases and not just relapse AML. And then we want to also be able to build on top of it and ingest data from clinical trial data from multiple sources and bring that all into the same tool. And then also design it to run it in data centers and also in the cloud like AWS. Next slide. So this is the web version of Gearbox. And on the left side, you'll see that this is where the questions exist. And on the right side are the clinical trials that are currently in the system. And so whenever a user will like input a patient's information on the left side, every time they answer a question, the backend essentially updates and will let a user know which trials are matches, are not matches, are still undetermined and require more information. Next slide. So as a overview of how it works, clinical trials are pulled from clinicaltrials.gov, and those are run through an NLP/LLM extraction process, which is then reviewed by a human, and this creates structured eligibility criteria related to the clinical trials, and that data is loaded into the application, which runs on the Gen3 framework. Next slide, please. So how do we use Gen3 for Gearbox? Next slide. Thank you. So pretty much what we did was we took Fence, Arborist, RepRoxy, Gen3 Helm, and Cloud Automation, Gen3 Terraform, and then we updated the data portal deployment in Cloud Automation / Gen3 Helm to use our own custom UI image. And so these things combined created a base structure, providing us with out-of-the-box authentication, authorization, networking service to deploy our UI, and then Terraform to create the Kubernetes cluster and all the other AWS resources, and then, of course, deployment files to get all this stuff running. And so kind of like taking this base, we were able to create our 2 custom backend services, Gearbox middleware and Gearbox backend, as well as our custom UI, and then plug all this into Gen3. Next slide, please. So how we created the custom backend services so that they were as compatible as possible with Gen3 was we picked a Gen3 service to use as sort of framework for a new service. So in our case, we used for Gearbox backend, Gearbox middle layer, we took metadata, the metadata service, and since we wanted to use Fast API, and the advantage of doing it this way is that it allows you to utilize the software updates from the Gen3 team for things that are not unique to your code. So for instance, the base Docker image and the other deployment files. And then from there, what we did was we copied the Terraform related to the original Gen3 service, and then we updated it. So we added any any additional Terraform that we needed and removed any Terraform from the metadata service that just wasn't needed for our specific use case. And then similarly, we took for Gen3 Helm, we copied the chart over and did the same process where we just updated it with our information. And then similarly, if you're still using cloud automation, the process is similar where you just have to update the scripts to add any sort of custom resources like an additional DB, and then create your Kubernetes deployment files and the kube setup file. And then finally added, just any additional things that you needed, and we were able to deploy it. But yeah, that's how we use Gen3 to create Gearbox.
Is that the final slide, Paul?
Yeah, that's the final slide.
Hey, this is fascinating. I'm not sure if I've heard of anybody using Gen3 in exactly the same way before, so it's a really interesting extension. Does anybody have any questions for Paul? All right. Well, we managed to finish a few minutes early, actually, so we have some more time if there's questions for any of the earlier talks, such as Jawad or Alan and Jimmy, where we didn't have the time. Or just opening the floor to questions on any topics.
It looks like there's a couple of questions in the chat.
Yeah. Okay, so the first question is from David Peters. Nice, lots of tools to manage multiple environments, clusters, commons. How do the speakers separate environments for specific commons, such as prod, dev, or UAT? Same cluster, different AWS accounts, different clusters, etc. You can read it. Do any of the speakers want to respond to that?
For CTDS, we do separate AWS accounts and then also separate clusters. Clusters, I don't think can span AWS accounts, so you do get that segregation automatically. The logical separation, basically.
For OCC, we basically have landed on going for separate AWS accounts for dev and prod instances. It just makes things easier in terms of keeping track of all the AWS resources. And it's possible that there's something we haven't thought of that would cause it to be better for clusters to be in the same AWS account, but separating them out seems simplest for us.
Yeah, we follow the same approach too. We separate them.
Same for Indiana.
Yeah. There's just so many benefits. I just saw a blog post actually recently from a SaaS company that works in AWS making the argument for why they, use separate accounts for all their tenants. It's a security ban. There's just so many good reasons. Keeping track of cost. It's trivial to do versus very, very hard if you're trying to do that within the same account. So we use separate accounts. And admittedly, we have a nice org setup. We have org admins who are happy to automate all that with Control Tower in AWS and similar tools on the Google side. So it's easy for me to say because I'm not an org admin. I just ask for new accounts.
I don't know if we got everybody. Paul and Luca, similar for your group?
Oh, we use separate accounts.
Yeah. Are there other questions from anyone?
I have a question. I know that you guys have understandably focused a lot on the benefits for each of your different approaches. I wonder if you could talk about, um, some of the limitations, like where are the instances or the conditions or environment that you would want to choose a different one?
That's a hard question, Sarah. Speakers, any things you run into that are you think are particularly maybe difficult for the way you've implemented things, or however else you want to respond to Sarah's question?
Something that we're doing right now, and it's sort of related to capacity management and cost optimization. And something I maybe think we should have done before is running a overlay network on our Kubernetes clusters. So I think that's also some of the topics for next CSOC working group if anyone is interested. But um, we have started using Cilium and we're going to start rolling it out into production. Cilium basically gives us another networking layer, so each pod doesn't get a real IP in AWS. That seems to be a constraint in how AWS does in their EKS nodes. There is an artificial limit on how many pods you can run per node because of the AWS IP thing. So even if your services don't require that much CPU and memory, you're stuck with basically excess compute that you're paying for in AWS. I don't know if that totally answers your question, Sarah, but that's something that I wish we had done earlier. And it's kind of cool to see like how much more we can squeeze out of each node now with Cilium, and that translates directly into cost savings. And we're able to run more Gen 3s with less hardware, basically, which is kind of cool in AWS.
Oh, sure. Thanks, Coach Jawad. And I guess I want to clarify. I think maybe I came across more aggressively than I meant to. No, I just mean like, so I think, for example, there was someone who talked about how their solution would only work in AWS, right? So if you're wanting to deploy outside of AWS, then you wouldn't choose that one. That's all I was thinking.
Yeah, so at our Story Commons, we at the moment we're 100% AWS. So we haven't quite uh, worked with any other public cloud. And in the future, we may have a few others in OpenStack, but at the moment it's all AWS, so that's why all the effort has been on AWS CDK. So once we get to that point where we need to deploy in OpenStack, so we may consider using probably Terraform if that works in OpenStack. I haven't worked with that yet.
Nice.
Anyone else want to take a crack at Sarah's question?
Concerning Crow, one thing that I have noticed is that in deploying Kubernetes manifests into the cluster, there's a lot of manifests to monitor. So if your resource graph isn't reconciling properly, you may need to start checking each of those resources to find out exactly where the issue is coming from. But since it's a graph, you can also check what has already been deployed and what's missing and find out exactly where the deployment stopped. So it's probably because the controller is currently under development right now, but they've made strides. I mean, they've made very large strides between December and right now. The resource graphs are reconciling properly. We have status updates. We can see whatever it is that has been deployed easily. But yeah, there's a lot of resources to manage within the CSOC cluster.
Can you remind us, Jimmy, when Crow might go into production? I think we've talked about this before, but I
Oh,
don't.
yes. It was supposed to be end of last year, but right now it's open-ended.
Oh, okay.
There is a lot of new features that they're trying to introduce that would make it a lot more robust. And since they have a lot of those, they haven't decided exactly when they're going to be done with it. But they're looking before the end of 2026, actually.
Okay.
Yeah.
Great. Any other questions from anyone?
Not a question, but if you do go with the Terraform route, I highly recommend checking out TerraGrunt for managing multiple environments. Unfortunately, since it manages all of our infrastructure, that repository isn't public, but I do believe we have something in our documentation on docs.gen3.org that goes over the TerraGrunt. Yeah, I can link that doc here, although I haven't looked at this doc in a while. I believe it's still factually correct. Yeah, it looks okay. But basically, you can then reuse the same Terraform templates and deploy them to multiple accounts. But yeah,
Great. Thanks, Jawad. So I guess I'd like to thank the speakers again. I think that today is a testament of all the interesting and powerful innovation that the community is doing around Gen3. So thanks so much for sharing your work. If you have ideas on future Gen3 forums, please reach out. We haven't quite, I think, settled on what the May meeting will include. So get in your ideas now. And I put in a link further up the chat for how to join the CSOC working group if are interested in learning more about any of the topics you heard today. So with that, thanks so much, everyone, and we'll see you all soon.
Great job, everybody.